Hi everyone, and welcome to TLDR Week 3, Malware and Vulnerabilities. The learning outcomes for the week, I want you to be able to talk about the different characteristics of different types of malware, explain what a vulnerability is and why they're dangerous, talk about various attack vectors such as worms, viruses, or social engineering, and analyze protection methods, including their likely effectiveness. Malware in general is the term that we use for software that is doing something bad. Now, there are different reasons that people will make malware. There are some people that make malware that are what we call script kiddies, which are basically like they don't really know enough to create something brand new, but they just kind of like playing with it. It's also got a little bit of a slightly ruder connotation in that it's usually people that don't really know what they're doing. You might also have some people that make malware just to see if they can. That's actually the origin of Mirai, was somebody who was just creating it to see if they could, and then they released the source code, and then it spread and mutated. There's also some black marketplaces where there are people who actually create malware as their job. You might also see some security researchers that will create what's called proof of concept, which is not actually malware. It's I've found a vulnerability and I'm proving that this is a vulnerability, which isn't exactly the same thing. Some really common types of malware that's out right now is ransomware, where the malware actually takes over the computer, encrypts all of your files, and then you have to pay to get access back. And then the other really common one is zombies. It means that it's malware that's going to take over a computer and use it for a more nefarious purpose. Viruses, they actually have to be run. Now, these are going to be some examples of specific types of malware. So, the overall term that we use for things that are programs that do bad stuff is malware, but there's actually different types of malware, viruses being one. Now, what makes it a virus is you have to run it to infect the system. The most popular ways that viruses get spread are email attachments and things like social media links or unknown shortened links, where you go to the link and then download something and run it that's bad. You'll also sometimes see viruses as torrents. So obviously you shouldn't be torrenting illegal things, but there's going to be some poison torrents out there that actually contain viruses instead of the latest movies. Worms come to you and they're self replicating, so it's not like you have to go to the effort of going to a website and installing something, they come looking for you. Trojans is specifically when we have malware that is embedded within another program. So let's say you are using a torrent to get an operating system. That's a legal use of torrents. You'll sometimes see some Linux operating systems downloadable as torrents because they're so large. If we had a Trojan, what would happen is you would have the legitimate operating system, but you would have a bad program within it. So part of what you would be doing is installing the operating system and it would come with a bad program. You'll sometimes see this with free software or freeware. And some of the freeware or shareware is the way that they make the money from it is they actually add something in and it turns it into malware of the specific Trojan type. There's actually a couple websites that are relatively well known that do this, that repackage free software and basically put junk in them. Rootkits are the worst. So, rootkits are worse than regular malware because they're actually going deeper into the system and they can also mask their intrusion a lot. So, rootkits are not something that you generally worry about with a user's computer. Normally, we see rootkits on servers. Rootkits on servers mean that they were somebody or a program was crawling around, attacked the server, and is actually able to include malware on the server at root level and then can go and sort of clean up its tracks so that people can't figure out where it came from. Antivirus software, how we prevent these viruses, there's a couple ways that this can work. One of the most popular ways that you'll see for general users is databases or fingerprinting. So if you have any free antivirus software, which as a note, the free antivirus software in general is perfectly fine. Something like Malwarebytes or AVG, the free version is just fine. The way databases work is we have something called a hash function. A hash is a one-way function where you take a program, run it through the hash function, and then you get a set of characters back out. What makes it a one-way function is there's no way to generate the program from the hash or those characters, let's say 16 characters. The way a database works is you have a bad program. That bad program goes through the hash function and you get your 16 characters back out. We would then save those characters in a database and mark it as a bad program. And every time we find a bad program, we're going to put it through that hash function, get our 16 characters back out, and add it to the database. So if you have free software, such as, let's say, Malwarebytes or AVG, and it says it needs to update the database, that's actually what it's doing. Now, something you'll see at the corporate level is behavioral diagnostics or micro-virtualization. What they'll actually do with some of the newer security appliances in industry is they'll actually take the program that they think might possibly be malware, but it doesn't match, say, the database, and they'll actually create a small virtual machine to run it and then see what it does. Does this behave like malware? Is it accessing things that it shouldn't? And then the program or appliance will make some guesses if it's malware based off of that. Now, the way that these different bad programs are found is through something called honeypots. I have 3 options of honeypot maps here because sometimes some work and some don't, and it's very much dependent on what's up and running. So you might have to try all 3. What you're going to see when you actually look at these maps is a live map of malware running across the world. Where you're seeing it hit is the honeypots, which a honeypot is basically a computer or set of computers that looks vulnerable and basically says, hey, come attack me, I'm all defenseless. And then the bad programs will attack, and then researchers can keep track of the bad programs that have come in, and they can see, are they new programs, are they variants of old programs, etc. So please take a moment to go to one or all of these different honey maps and of honeypots and go check them out. Feel free to pause me. Email is a popular way that you'll see malware come through. Now there's the sort of chainmail, forward this, chain letter type thing, which isn't really malware, it's more of a nuisance. What you'll see more often is embedded links, spam, and phishing. So everybody gets spam. That is emails that are basically junk that you don't want. Embedded links are a more dangerous thing that can happen, where if you look at the email, sometimes it'll say things like, click here to confirm. And then if you hover over that with your mouse, you can actually see where it's going to. Now, sometimes what'll happen is those embedded links will go somewhere that is not where it says it's going to go. It goes to, for example, a phishing site. You'll also see some of the more clever spam providers will actually use shortened links, so you can't see where it is. You actually have to go to a link expander to figure it out. That's why it's generally not a good idea to click on links from your email. It's better to go to the actual web page. Phishing is when we send out emails and try to get people to click on things or put in their credentials in a site that looks valid but isn't. If you end up staying with me through advanced security, we're actually going to talk about how to create phishing sites, and one of the demos that I do is actually basically showing you one of the tools that can create a site that's an exact copy of a real site, but phishing. It's pretty cool. This is actually websites and spoofing. So what we can do is actually copy a legitimate website, like for example, Facebook, and everything will look like Facebook, and we can even have it redirect to real Facebook, but you get to sniff the credentials or see what the login information is when people do that. We'll see this a lot with fake URLs. So if you have, for example, google.com, that's a real URL, but if you spell it wrong or add in sort of, they call it like fat finger typing, where you have like GOLLG.com or something like that. If Google hasn't actually bought that address, that could potentially have somebody else that buys it and makes a site that looks like Google but actually isn't. You also sometimes see scareware online. What's becoming more popular is the pop-up ads that say things like, you have a virus, click here to fix it, or some of the redirect ads where it will actually take over or redirect the page somewhere else and you can't get back. You'll see a lot of that with, congratulations, you're the 1 millionth winner, click here for your free iPad or whatever. Social media and fake news is something that is more important the more that time passes. Things like viral news stories and the concept of trust on the internet is getting to be a much bigger problem than I think a lot of people anticipated. Now, some of this is because people that grew up on the internet know exactly how easy it is to share opinions on the internet. Spoiler alert, very. People that grew up before the internet are used to a more trustworthy news source. So before the internet, there was actually a news anchor whose name was his name is Walter Cronkite, and what actually happened was they had only one, two, or three channels, depending on how far back we're going, on the TV. And this news anchor would come and literally read the news that was pre-decided on for half an hour, and that was all the news you got in a day. Now, that's a very different concept than what we have now, which is multiple channels of all the news all the time. What people call news is also very different, and the way news spreads is very different. A perfect example of this is if you go on any social media ever, you can see a lot of people that will share things without actually checking what they're sharing. As of summer 2020, there's actually quite a bit of controversy about this right now, especially with the elections in the United States coming up. Some social media has actually gone to trying to fact check what people are posting, which of course is going to come with the issue of, well, is that actually a fact? Who's fact checking? What's their bias? But social media, fake news, people sharing things, this is actually all part of information security, in that if we have things that are being shared that are false, that can actually potentially be really harmful. From the very obvious, click here to win an RV, and then people click and your information gets stolen, to the less obvious rumors and conspiracy theories that are currently being spread all over social media. Another vulnerability that we can have for malware is actually updating software. So the two paths here are update the software or don't update the software. If you do update the software, you actually run the risk of it breaking things. One of the problems that happens with Microsoft's Patch Tuesday is the software that is being patched can actually break your system, in that some software will stop running, or you'll have booting problems, things won't start up. And of course, the other side of, okay, well, that doesn't sound good, let's not update it. If you have a bug that they've sent out a patch for and you haven't updated it, you're actually more vulnerable than you were before, because once they've reverse engineered the patch, it's basically like a big glowing red arrow that says vulnerability here. And so both paths have kind of pros and cons that you have to decide if you want to do. A 0-day exploit is an exploit that has just been found. So a 0-day exploit is basically like this is a new exploit or a new vulnerability or a new problem that people have found. Now, there's actually some people that a vendor is somebody who creates the software. We can have vendor created patches. So for example, Microsoft is going to patch Windows. We can have non-vendor created patches where something is serious enough, like the new one this summer, which was the Grub bootloader, had issue. So there's actually a bunch of people working to try to fix that, and technically that's a non-vendor patch. There's also the problem of people that sell 0-day exploits. Now there is of course bug bounties where if you find a bug you can potentially get paid for it. But there's also people that will find and hoard 0-day exploits and then ransom them to companies or governments and things like that, which has its own set of ethical issues that I hope you all see. Hardware and networking gives a unique set of vulnerabilities because when most people think of malware or viruses, they think of their computer. Oh no, I'm worried about getting a virus on my computer. They tend to not think of things like, for example, your router or your printer or your smart home devices. Those are actually also all vulnerable to different viruses and malware as well. Printers are actually a really well-known pivot point that some hackers will go for because most people not only don't update their printers, but a lot of printers are internet connected and basically punch through the firewalls so that you can access them from other places. So you have something that has a chipset on there, everybody connects to it, is connected to the internet, and hasn't been updated. So you can see where that would be a vulnerability. Switches and routers basically have the same sets of vulnerabilities. So you want to make sure that when you're talking about malware and protecting against malware, you expand beyond just, oh no, my computer. Now, social engineering is one of the pieces of vulnerabilities that is just getting bigger. Social engineering as a whole is the idea that we're hacking the wetware instead of the hardware. So if I needed to get, let's say, information and steal information from a company, sure, we could go about trying to, case the joint. We could try to exfiltrate the data. We could try to find vulnerabilities in the servers. Or alternatively, I could call, pretend to be somebody I'm not, see if I can get the login of somebody high enough up, log in, and then just send myself everything. So social engineering is becoming a much bigger vulnerability and is also one of the, I don't want to say easier, but it's a different way of looking at security. People are a much bigger vulnerability in companies than a lot of security people in the security community, I think, thought. We're going to talk more about social engineering next week. Now, the assignment for the week is actually going to be doing a little bit on your Mint machine, practicing running some commands so that you can get some practice with the command line. And I'm also going to have you do wpscan on Kali. Now, when you use wpscan with Kali, you're going to run it on the Northern Essex website. I would like to be very clear here that you can run wpscan on the Northern Essex website. You cannot do anything else. Do not do enumeration. Do not try to brute force passwords. Do not do any of the other intrusive scans. A very passive, non-intrusive scan is the only thing that you are allowed to do on the website. I'm also going to have you do a little bit of a write-up on what wpscan is for, why it might be useful, so that you can start to see how some of the vulnerability testing works. If you have any questions, please let me know.